heat transfer. Difference between boiling and evaporation. In both boiling and evaporation, matter changes from liquid to gas. But the two processes are quite different. When temperature of a matter increases, the particles of the matter gain energy and move with greater speed. In evaporation, the particles at the surface escape and form gas. So, the process of evaporation takes place at the surface. Thus, evaporation is a gradual vaporization of a liquid on the surface. On the other hand, boiling is a rapid vaporization of a liquid only when it is heated to its boiling point. In evaporation, no bubbles are formed, whereas in boiling bubbles are formed. Boiling occurs throughout the liquid, but evaporation occurs only at the surface. Evaporation occurs at all temperatures, whereas boiling occurs at definite temperature boiling point. For evaporation, energy is supplied by surroundings. For boiling, source of energy is needed. Boiling occurs rapidly, whereas evaporation occurs slowly. The motion of particles is fast in boiling, whereas in evaporation, few particles move slowly and few at a faster rate. Thermal expansion. Almost all solids, liquids and gases expand on heating. The increase in the size of a body when it is heated is called thermal expansion. There are three types of thermal expansion. 1. Linear expansion. It is the increase in the length of a metal rod on heating. 2. Volume expansion. It is the increase in the volume of block on heating. 3. Superficial expansion. It is the increase in the surface area of a metal sheet on heating. Linear expansion. Suppose L be the original length of a solid rod. Let L be a small increase in the length of the rod when its temperature is raised by a small amount T. Thus, it is found that L is directly proportionate to L and L is directly proportionate to T. Therefore, L is directly proportionate to LT. Volume expansion. Suppose V is the original volume of a solid. Let V be the small increase in volume of the solid when its temperature is raised by a small amount T. Thus, it is found that V is directly proportionate to V and V is directly proportionate to T. Therefore, V is directly proportionate to VT. Superficial expansion. Suppose S be the original surface area of a solid. Let S be a small increase in area of the solid when its temperature is raised by a small amount T. Thus, it is found that S is directly proportionate to S and S is directly proportionate to T. Therefore, S is directly proportionate to ST. Thermal expansion of solids. When a substance is heated, it absorbs heat and starts expanding. That is, most of the metallic solids expand on heating. The gases expand the most and solids expand the least on heating. Unlike gases or liquids, solid materials tend to keep their shape when undergoing thermal expansion. Thermal expansion generally decreases with increasing bond energy that affects on the melting point of solids. So, high melting point materials have lower thermal expansion. Let us perform an activity to observe thermal expansion in solids. Activity. An iron ring ball apparatus consists of a metallic ring and metallic ball. The outer diameter of the ball is equal to the internal diameter of the ring. Initially, the ball easily passes through ring. Now, heat the ball strongly for a few minutes. You will observe that ball does not pass through ring because its diameter has increased. After some time, when the ball is cooled, it again passes through the ring. This shows that solid expands on heating and contracts on cooling. Different substances of identical dimensions expand by different amounts when heated through the same range of temperature. Let us perform an activity to observe this difference in expansion of different solids. Activity: take a strip made of two metals called bimetallic strip, such as brass and iron. The strip looks flat at ordinary temperature, room temperature. Heat the strip over the flame of a Bunsen burner for some time. Observe what happens. You will find that the strip bends due to heating, such that brass is on outer side and iron is on inner side of the curved end. It shows that equal length of brass and iron, different metals, are heated for the same time with same range of temperature, yet have unequal expansion, that is, brass expands more than iron. This forces the strip to bend towards the iron side. Practical applications of thermal expansion of solids. 1. While laying the railway tracks, some space is left between the joints of railway lines. This is done because during excess heat, the temperature rises. If the rails are fixed tightly, leaving no space for expansion, they will bend in summer and may cause derailment of trains. Hence, to avoid it, some space is left between the joints of railway lines. 2. For the wooden wheels of tongas, the iron rims are made of the same size as the wheels themselves. The rims are heated before fitting so that they expand and fit over the wheels. After fitting, cold water is poured over the rims. On cooling, they contract and grip the wheels firmly. 3. In construction of bridges, some space is left to allow the expansion to take place during high temperature. Therefore, during the construction of a bridge, one end is fixed and the other end is mounted on a roller to accommodate the expansion or contraction during the change in temperature. Thermal expansion of liquids. Liquids also expand when they are heated. Let us see with the help of an activity. Activity: take a test tube and fill it to the brim with water. Take a rubber stopper and make a small hole in it. Put it on the mouth of the test tube. Put a small capillary tube through the hole in the cork. Water will rise in it. Now, heat the test tube. You will notice that the water will rise further in the tube. This shows that liquid expands on heating. Example: thermometer is one of the application of thermal expansion of liquid. Thermal expansion of gases. Expansion in gases is maximum than in solids or liquids because the molecules in a gas are very loosely packed. On heating a gas, the molecules move far away from one another. Thus, the gas tends to increase its volume. Activity: take an empty flask and fix the balloon to its neck. Heat the flask using a burner and observe the balloon. After some time, the balloon gets inflated. Now, leave the flask to cool down. The balloon gets deflated. It shows that gases expand on heating. Hot air balloons. The interesting example of expansion of gases is hot air balloon. Hot air balloon inside the balloon bag expands more quickly than the outside container. So, it stretches the bag so that it expands and displaces the colder air outside the bag. Scientist: Anders Celsius was a Swedish astronomer. He was professor of astronomy at Uppsala University from 1730 to 1744 but travelled from 1732 to 1735, visiting notable observatories in Germany, Italy and France. He founded the Uppsala Astronomical Observatory in 1741 and in 1742 he proposed the Celsius temperature scale, which takes his name. Celsius conducted many geographical measurements for the Swedish general map and was one of the earliest to note that much of Scandinavia is slowly rising above sea level, a continuous process which has been occurring since the melting of the ice from the latest ice age. However, he wrongly posed the notion that water was evaporating.